Hello and welcome to our video solution to problem 5 from Superquiz 2. This problem actually refers to problem 4, but I've copied the relevant information in. So it's asking you to use a line integral to compute the arc length of a helix, and the parameterization for that helix is given down below here. So maybe we give a name to this curve, we could call it C. But the parameterization is actually what we need, and we need to know how do we use a line integral to compute the arc length of a curve. And the answer is quite simple. You just integrate the constant function 1 over the curve. Okay, so remember the reason why that is, you think about what a line integral is doing, you're multiplying the value of the function on some little interval times the length of the interval, and then adding up all those values. Well, if all you want is the arc length of the entire curve, then you should just be adding up those teeny little arc lengths, right? You chop up the curve into little pieces, keep going. Each one of these little pieces is what we call ds, right, in terms of the length, and you add up all those little pieces, that should give you the whole curve. So you don't want the function to give you anything new. So we just want to integrate ds. So in the previous problem, we actually computed this ds to be the square root of 2 times dt. And so this arc length formula will just be integrating t from 0 to 4 pi, and then we'll have root 2 dt. Well, of course, the root 2 can come out, and then we're just integrating the length of the interval, right? Which is actually very similar to this setup here. All right, let's write that down quickly. You integrate from 0 to 4 pi just dt, right? This is just saying add up all the little dt's, right? You chop up some interval from 0 to 4 pi, chop it up into little teeny pieces. Each one of those is a dt. Add them together, you'll just get the length of this thing, which is 4 pi. So we'll get 4 pi times the square root of 2, and that is the length of the helix.